Okay, in preparation for talking about AC analysis, we have to talk about complex algebra. So first, there's a few things we need to discuss about complex algebra. One, how to add and subtract complex algebra. So we have generally something of the form A plus JB. We use J because I is reserved for current, and similarly A minus JB. If we were to convert them into polar form, we get r angle theta, where r is equal to the square root of their quantity squared, and theta is equal to tangent inverse of b over a. However, for this one, it's not necessarily as simple as just finding an angle. We have to consider a few cases. First, case 1, A and B are both positive. Then that means that the tangent of inverse is just equal to theta. So that's okay. If A is greater than 0, but B is less than 0, then we have to actually let's talk about this case first. If A is less than 0 and B is greater than 0, then we have to take the tangent inverse. We have to take 180 degrees, subtract it from tangent inverse of B over the absolute value of A, and that will be our angle. If it's in the situation that this is negative and this is also negative, then we have the third quadrant. It's going to be 180 degrees plus tangent of B over A equal to theta. Now, the situation where A is positive but B is negative, we just simply get negative tangent inverse of B over A as our reflected angle. And that's basically all we really need to know about just the brief idea of complex algebra. Now, in terms of operations, there is a few things we have to keep in mind. So, one, how do we add two complex quantities together? So let's consider z1 plus z2. In terms of a1 plus jb1 plus this, we just have the following. We combine their real quantities together and their imaginary quantities together, giving us just a1 plus a2 plus j b1 plus b2. A similar operation for if it's subtraction. Now, what happens if you multiply them together? Well, in this situation, it would be preferable to talk about them in terms of complex or in terms of polar coordinates. So a1 plus jb1, a2 plus jb2 is much better talked about with r, with calling this r1 theta 1, and then right here r2 theta 2. So we have r1 times r2, and then the multiplication of these two is angle 1 plus angle 2, like that. So anytime you have two quantities, two complex quantities that multiply together, it would be better to talk about them in polar coordinates, which gives us this following property, that the poles multiply together, but the angles add. Like so. A similar idea exists for division. Now, suppose you wanted to find the complex quantity in the situation that there is just Cartesian or just regular rectangular coordinates. So you want to define z1 divided by z2. a1 plus jb1 divided by a2 plus jb2. Well, we have to do what's called a complex conjugate, which is we have to multiply the top and bottom by the negative of this quantity. So we have a2 minus jb2 divided by a2 minus jb2. And we're not violating anything by doing this. This is just the same as multiplying by 1. This therefore gives us a1 plus jb1 times a2 minus jb2 divided all over a2 squared plus b2 squared. And then on top, we can probably reflect this as r1, r2, angle theta 1 minus theta 2. And then this one is just r2 squared, just to give an idea. And that's just all the operations we really need to know for doing complex algebra and in preparation for AC signals. Okay, thank you.